In this video, we are going to learn about Lewis dot structures for atoms, ions, and ionic compounds. Previously, we learned about the Bohr model of the atom, where electrons occupy shells around the nucleus. Shown here are Bohr models of sodium, magnesium, and fluorine. We also learned that the outermost electrons are called the valence electrons. Sodium has one valence electron, magnesium has two valence electrons, and fluorine has 7 valence electrons. Valence electrons are the electrons involved in chemical bonding. When forming compounds, Lewis dot symbols represent only the valence electrons as dots around the element symbol. They provide a quick way to visualize how atoms bond together. When drawing Lewis dot symbols, imagine a square around the element symbol. Since the square has 4 sides, place one dot on each side before pairing any electrons. It does not matter which side of the imaginary square you begin with. For sodium, we draw one dot because it has one valence electron. Magnesium has 2 valence electrons, so we place one dot on each side of the square. 2 different sides. Fluorine has 7 valence electrons. Begin by placing one electron on each side of the square before adding additional electrons to form pairs. The completed Lewis dot symbol has 3 sides with paired electrons and one side with a single unpaired electron. The periodic table provides a convenient shortcut for determining the number of valence electrons for the main group elements. Look at the group numbers. Group 1 has 1 valence electron. Elements in group 2 have 2 valence electrons. Group 13 has 3 valence electrons. This pattern continues across the periodic table. The noble gases in group 18 have 8 valence electrons, with the exception of helium, which only has 2. When forming ions, atoms tend to gain or lose electrons so that they have the same number of electrons as the nearest noble gas. For instance, sodium tends to lose one electron to have the same electron configuration as neon. Fluorine tends to gain one electron to achieve the same electron configuration as neon. When drawing the Lewis dot symbols for ions, we begin with the Lewis dot symbol of the neutral atom. Sodium has 1 valence electron as a neutral atom, so as a sodium ion, it will have no dots because it lost that 1 electron. Fluoride has 8 dots, the original 7 plus the 1 it gained. Charged ions are drawn inside square brackets with the charge written outside the square brackets in the upper right-hand corner. Let's try a practice problem. Draw the Lewis dot structures for the following atoms and ions: oxygen, calcium, calcium 2 positive ion, argon, boron, and the sulfide ion. Oxygen is in group 16, so it should have 6 valence electrons. Place 1 electron on each side before pairing. The completed Lewis dot symbol has 2 lone pairs and 2 unpaired electrons. Calcium is in group 2, so it has 2 valence electrons. Draw 2 unpaired dots on different sides of the square. The calcium 2 plus ion has no dots because it lost both of the valence electrons it had. Argon is in group 18, so it has 8 valence electrons. Each side of the square contains a pair of electrons. Boron is in group 13, so it has 3 valence electrons. Draw 3 unpaired dots on different sides of the square. Sulfur is in group 16, so a neutral sulfur atom would have 6 valence electrons, just like oxygen. However, the sulfide ion has gained 2 additional electrons, giving it a total of 8 valence electrons. Now let's look at Lewis structures for ionic compounds. Ionic compounds are made out of oppositely charged ions. The ions always combine so that the total charge is 0. A neutral sodium atom has 1 valence electron. It loses that electron to become a sodium plus ion. A fluorine atom has 7 valence electrons. It gains 1 electron to become a fluoride ion. Because sodium loses 1 electron and fluorine gains 1 electron, 1 sodium ion combines with 1 fluoride ion to become sodium fluoride. The Lewis dot structure for sodium fluoride is simply the Lewis structures of the respective ions written next to each other. Here is the sodium ion, here is the fluoride ion. Now consider magnesium fluoride. Magnesium has 2 valence electrons, so it had to lose both electrons to become a magnesium 2 plus ion. Each fluorine atom can only accept 1 electron, so 2 fluoride ions are needed to accept the 2 electrons lost by the magnesium. The Lewis dot structure for magnesium fluoride consists of 1 magnesium ion and 2 fluoride ions. The magnesium ion may be drawn between the 2 fluoride ions, or the 2 fluoride ions may be grouped together with the 2 coefficient written outside the brackets. Both representations communicate the same chemical formula.